Hello, I was asked by somebody to provide a real world-ish type example about a confidence interval, kind of like I did the other day when I was talking about happiness and the role of a p-value and alpha. So here, sample size. So I created this example here, and this individual asked, provided an kind of a template for me thinking about elections. Okay, well, that's what I usually do when I talk about confidence intervals in stats class. So I decided to create a scenario where you have two candidates. Candidate A it's being reported in the news that candidate A has an estimated 60% of the vote in a specific precinct based on exit polls after interviewing 25 individuals. So that means our sample size is 25. Our expected value, when we get an estimate like 60%, that represents an expectation. It's an expected value, just like we were talking about the other day, the sampling distribution of the mean. You saw these little samples within a population, and one of those has an expected value, an expectation, same as the mean of 60%. So the question is that a good representation of the way that precinct is voting? When you hear that on the news, you think, oh, wow, my candidate has 60% of the vote. Most people treat that as it's truth. It's an absolute fact. But we don't know that. Well, now, hopefully, you know now, based on the idea of the sampling distribution, this could be a real value or it could be an accidental finding based on something. Who knows? Maybe it's just that this reporter spoke to a bunch of people that came in a group together and voted for a specific candidate. So we have no idea if this is the real voting result. So I just drew a null excuse me, a normal distribution here with a mean. So it's a Greek, it's a Latin letter because it's a sample. It has a mean of 0.6. So we don't know what the population mean is, right? And it has a standard deviation of 0.15, right? So that's if you can put that in terms of uh of the empirical rule. So that's why I kind of drew the lines here for one standard deviation above and below the mean, two standard deviations above and below the mean. But what I'm wanting to report is a 90% confidence interval. Why I chose 90%? Well, it's interesting, even though in stats we talk about 95% confidence intervals, lots of times in the real world outside of a statistics textbook, people talk about 90%, 99%, different confidence limits. They're not always limited to 95%. So I just picked 90% confidence interval. So we need to calculate a margin of error, and then using that margin of error and what we know about the standard normal distribution, we're going to provide a confidence interval. Why pick the standard normal distribution? Because hey, we don't know what the true population standard deviation is. We don't even know what we don't even know what the estimated population mean is, right? But we do have these sample values, and we're going to kind of just estimate where the true population could be. So I'm just going to pick a Z distribution, a standard normal distribution here. I can do whatever I want, right? In this case here, but I'm going to use this standard deviation as my estimate of the true population mean. I'm not doing a statistical test here. I'm not comparing it to a value. So one could say, well, why don't you use a t-test here? Because you don't have the population standard deviation. I don't have any value about the population at all. So I'm just going to create an interval here. I'm going to kind of play around with the idea that as the sample size gets larger, we're going to approach normality anyway, the central limit theorem. All right, so let's take a look at what our standard error would be. If you recall, I mentioned that the standard error is the standard deviation of the sampling distribution of the mean. If we take the mean of every possible sample from this population and we just use those means as our data and get the standard deviation of those means, we'd have the standard error of the mean. All right, so let's go ahead and calculate that. We know the equation for the standard error here is the standard deviation divided by the square root of the sample size. All right, so I have a sample size of 25. I have a standard deviation of 0.15, and I'll use that for my calculation. to calculate the confidence interval, I'll take my point estimate, which is this 0.60 or 60% of the vote. I just use it as 0.60. I add and subtract to it the margin of error. The margin of error is going to be some cutoff point based on the normal distribution times that standard error. Well, what I'm using here is a cutoff that excludes the top 5% of the distribution and then the bottom 5%. What's left over is the middle 90% of the distribution. That 90% includes this as our population mean, because this is our estimated population mean, our point estimate, right? So surrounding that, we have 90% of all possible samples from this other population here with a mean of 60%, right? So anything within here is really representative of this population. Anything outside of there is not. So we'd be confident that the true population mean value would be between minus 1.645 and plus 1.645, right? Somewhere in here, right? With this being our point estimate, okay? But confidence is going to be somewhere between there. So I take my point estimate, I add and subtract this margin of error from it. Oops, sorry about that. I don't know my powers. I have odd powers when I'm working with computers. Yeah, I add them and subtract the margin of error from it. So my margin of error is 1.645 times 0.03 times my standard error, and I get 0.04935. I subtract that from 0.6 and add it to 0.6 because again, my confidence interval surrounds this mean, and it is 0.551 and 0.649. So how would I report this if I was this sagacious reporter? I would say to my audience that our estimate of the population precinct voting for candidate A is 60%. So they get 60% of the support. However, we're 90% confident that the true population value, again, this is our estimate of the precinct population proportion voting for candidate A, but we're 90% confident that the true proportion is as low as 0.551 or as high as 0.649. So it's somewhere in between there, okay? And that's how I would interpret this confidence interval. Thank you very much.